Today we're going to work a little bit with proportions. We're going to talk about some strategies for solving a proportion and what that means. A proportion is made up of rates or ratios. So a proportion is an equation. It has an equal sign in it, but it's just a statement that says that two ratios or rates are equivalent. So what equivalent means is that if you simplify them, they're the same thing. So for example, I could take 1/2, and we know that 1/2 is the same as 5/10. So those equal each other. They're equivalent because they simplify to the same thing. So when I make that statement and I put that equal sign in the middle, that's when I get a proportion. So this is a proportion. That is what we're going to be working with a little bit today. If you have equivalent ratios, so like the 1/2 and the 5/10 we just had, then if they are equivalent, they simplify to the same thing, then we say that they are what we call proportional. We're going to talk about a couple of things today. One thing is this idea of solving proportions. So solving proportion is something you do when you're missing information in a proportion. So if we look at this proportion, 2/3 is equal to x over 5. So we know that this equal sign in the middle tells us that these proportions are equivalent. So if we were to simplify them, they would have the same value. They would be the same thing. The tricky thing is that we can't actually simplify thirds and fifths, which makes it a little bit harder to compare what's going on. So if we're trying to figure out what this missing value is that's supposed to match the two, another way that we could do that would be with a common denominator. So that's our way one, or one way to solve proportions is to make a common denominator. So if I have thirds and fifths, I can make a common denominator of 15ths. So I can rewrite both of these so they are out of 15. So this one, I'm going from 3 to 15, so I would need to multiply the top and the bottom both by 5. 3 times 5 is 15. 2 times 5 on the top turns this into 10 out of 15. The other fraction, I'm going from 5 to 15, so that one's going to get multiplied by 3 because 5 times 3 is 15. Now I don't know what this x is on the top, but I know that whatever number that is, I have to multiply it by 3 when I make my common denominator. Since I don't know what that is, I'm just going to leave it as 3 times x, or another way of writing that would be 3x. Whenever you have a number and a variable next to each other like that, it means to multiply. So now I end up with this. Now the interesting thing here is that the denominators are the same, and I've got this equal sign that's telling me, hey, these things are supposed to be the same. So if they're supposed to be the same and the denominators are exactly the same, in order for them to actually be equal, that means that the numerators also have to be the same. So this top green part, if the bottom's the same, 15 and 15, then that means those two things on the top also have to be the same. So I can focus in just on that top part, and I'm going to bring it down. I'm going to say, okay, so this 3 times x, whatever it is, I know that it's supposed to be the same as the 10. So 3 times x equals 10. So now I can use some of my solving equation skills. If I divide both sides by 3, I can figure out what x is. So this doesn't give a whole number, but you could go ahead and write that as a fraction. So 10/3, if you wanted to convert it to a mixed number, is 3 1/3. So that's what x has to be in order to make these equivalent. So if we go back to our original problem, a ratio of 2 to 3 is the same as a ratio of 3 1/3 to 5. That's what we just figured out. Now, that's a little bit of work to go through the steps and make a common denominator when we don't even end up using the denominator. The part that we end up using is just this top part. It's just the numerator that we ended up using to figure out our missing information. So there are some shortcuts that we could take through this process that basically let us shortcut straight to this numerator equation. And it has to do with what happens when we make our common denominator. So when we made our common denominator, in order to get the 10, we took the 2 and we multiplied it by 5. Well, that also happens to be the denominator of the other fraction. And that's how we got the 10. Now, the 3 times x on the other side. That we got when we had to take the original numerator, the x, and multiply it by 3. Well, again, that happens to be the denominator of the other fraction. So in the process of making a common denominator, we ended up taking each numerator and multiplying it by the opposite fraction's denominator. So in order to get 10 over 15, we ended up doing 2 times 5, and that's where the 10 came from. Same thing with the other fraction. When we made the x over 5 into 15ths, we ended up multiplying the x by the opposite fraction's denominator. So we ended up doing 3 times x. So rather than going through all the steps of showing the common denominator, a lot of people like to take a shortcut because in the process of making that denominator, you end up doing what we call cross multiplication, multiplying each numerator by its opposite denominator. So a lot of people just cross multiply and it will take them straight to the numerator or the green equation that they need to solve to find what they're missing. So the shortcut would be what we call cross multiply. And again, that looks like this. If I take my starting fraction or starting proportion, I'm going to rewrite it. We would multiply the opposite numbers, so 2 times 5 gives me 10. And if I multiply the opposite way, I don't know what x is, so I have to leave it as 3 times x. But that lands me on that same equation that I ended up with when I made the common denominator. So again, it kind of saves us all of this work over here, having to do all of that work of making a common denominator, and takes us straight to the equation. When you use cross multiply, that gives you the kind of equation that you're working with, but from there you do still have to solve the equation. So you can write the equation, but you would still have to show the dividing both sides by 3 to get the x equals 3 1/3. So those are the two ways that you can solve a proportion. So one way you can make a common denominator, or you can shortcut through that same process with a cross multiply strategy. So that's one thing you should be able to do, is solve a proportion, and that gives you some strategies to do that. Another thing you should be able to do is use what we know about proportions to decide if things are what we call proportional. So if they're proportional, we said that the ratios should be equivalent, or when we simplify them, they should have the same value. So we're going to look at an example of how to test that, what that looks like. So this is an example problem. So paying $12 per 16 yards of fabric versus $9 per 24 yards of fabric, we want to know if those are proportional. In other words, we want to know if we're being charged at the same rate. So there are a couple of different ways that we can figure that out. So one way would be to compare the unit rates. So if we start with our starting rate, so $12 for 16 yards versus $9 for 24 yards. We can calculate the unit rate. That is something that we learned how to do in an earlier lesson. So if you remember, to calculate the unit rate, we want to make both of these have a denominator of 1. So basically, we want to scale it down to find the cost just for 1 yard. So the way we would do that would be by dividing everything. So to get from 16 to 1, we have to divide by 16. That also means we have to divide our $12 by 16. And that gives us a price of 75 cents. If we come down here, the other one's 24 yards. So to get from 24 yards to 1 yard, this one we would have to divide by 24. But that also means we have to divide the $9 by 24. That gives us a price of, to the nearest cent, about 38 cents per yard. It's actually 37.5 cents, but we don't have half cents in our currency, so we round to the nearest cent when we have a situation like that. So what we just figured out is that these do not have the same unit rate. So that means that this is not proportional because the unit rates are different. In order for it to be proportional, the unit rates have to be the same. So our final conclusion here, if we're being asked, are these proportional, would be that they are not proportional. So that's one way, if you're asked if things are proportional or if they're following the same rate, would be to find the unit rate, because then you have a fair comparison, 1 unit to 1 unit. It makes it easier to compare and see what's going on. A second way that you could do this would be to use our cross multiplying or our cross product strategy. That strategy that we use, the cross multiply strategy we talked about in a minute, it works based off of this idea that we're making a common denominator that's going to make the denominators and the numerators the same. So in other words, it will make the two rates exactly the same. So if the rates really are the same, if I multiply diagonally, I should get the same answer both directions. And if I don't, I know it's not proportional. So that would be way 2, would be to take this and set it up as a proportion. And I'm trying to figure out, I'm going to put a question mark here because we don't know for sure if it is, if 12 over 16 is equal to 9 over 24. So the other way that you could do this would be to take your cross product, so multiply 12 times 24, and that gives you 288. And then if I multiply the other way around, 16 times 9, that gives me 144. Well, those are not equal. So again, that takes me to that final conclusion that these are not proportional. If they were proportional, I would get the same number both directions of multiplying. So that gives you a couple of different ways that you can check and see if a relationship is proportional relationship, if it's following a consistent rate or a consistent pattern. What you're going to do next is you're going to move on and you are going to try the You Try section of your notes. Before you start on the You Try section, you should look back through your notes and make sure that your notes match what was shown to you in the video. So you'll notice that I have a copy of your notes that I worked through with you. So your notes should match my notes before you start your practice problems.